So remind me what a system of equations is. You're showing me with your hands. Tell me with your words. Remind me what a system of equations is. So more than one equation? Okay. Is it two equations? Any number of equations. It depends on the number of variables, okay? So however many variables I have, that's how many equations I need, right, to solve a system? Where's the solution? It's a point, right? So the point where they cross. If we have two linear systems, we're looking for the ordered pair where they cross at, right? Or not two linear systems, two linear equations, excuse me. Two linear equations at the point where they cross, okay? If I have three variables, that means I've got three different planes. It's still the point where all those planes meet, right? So is it always one solution? It could be other possibilities, right? What are the other possibilities? No solutions or infinitely many solutions, depending on where those lines or planes lie, right? Okay, so what would a system of inequalities be then? So instead of having an equal sign, it'll have either less than, greater than, less than or equal, greater than or equal. Do you know there's one more inequality sign? So not equal, right? For the record, we're not doing any of those. We're only going to be doing less than, greater than, less than or equal, greater than or equal. Okay? So a system of inequalities, then how many solutions would be there to a system of inequalities? Okay, just as a reminder, if I have an equation, I graph it on a number line, or excuse me, on a coordinate plane, I graph that, and then I graph the other one, and where they cross is the answer, right? Is that right? Okay, system of inequalities, I graph the equation, and then to get the inequality part in, I shade, right? Either above or below. Now, the only time that doesn't work is when I have a vertical line and there's no above and below, but then I have left and right. You okay with that? Okay, but so if I've graphed this line and shaded, and graphed this line and shaded, where is the solution? Where they're both shaded, right? So double shaded. So what we want to do is we really want to avoid double shading. Okay? Double shading can be pretty confusing at times. So we want to avoid double shading. So we're going to do just a little bit of a shortcut right there, where we're going to draw a line and then tell ourselves where to shade. And then draw the other line and tell ourselves where to shade. And then we're going to shade once. I'm not saying double shading is wrong. I'm saying it gets confusing sometimes. Does that make sense? So let's start with this inequality right here. Y is less than x plus 4. I'm going to go ahead and give you the whole system so we have it. Okay? And then y is greater than negative x minus 6. That's my system of inequalities that we're going to start with. So let's graph the first equation. Excuse me, it's not an equation, it's an inequality. But let's graph the first one. And I put a green star by it because I'm going to graph it in green marker so we can tell the difference. No, you don't have to star it. I'm just telling you which one is which to keep it less confusing. Okay? So how do I graph this first one? Up 4 on the y-axis because that's my y-intercept. 1, 2, 3, 4. What's my slope? 1. So from this point I go up 1, which direction? To the right one. Now, you know and I know that it only takes 2 points to make the line, doesn't it? But if I draw all the points, I can see the line really, really clearly, and it doesn't take that long. Does it? Well, the other thing about it that's really nice is look at my inequality sign. I don't have to make it a solid line. What kind of line do I make it? Oh my gosh, I already have a dotted line. Now, I could go and put dashes if I wanted to, because a lot of people call this a dotted line or a dashed line. Dotted or dashed. Okay, those things here in this situation pretty much mean the same thing. Okay, dashed lines are sometimes a little easier to see, but it's really up to you. Okay, and I'm going to tell myself right now where I would shade. Look at the inequality sign. Less than, so I'm going to shade below. I'm going to shade below the line. Okay, it's less than, so it's going to be below the line. Here's how I'm going to tell myself where to shade. I'm going to say I would shade below the line if I was going to shade right now. And like I said a minute ago, you actually can go and shade, but sometimes double shading can get confusing. Okay? Is it? Okay. So let's try this one. How do I graph that one? Down 6. 1, 2, 3, 4, 5, 6. And then from this point I go down 1, right 1. Right? Because I have to have a negative slope. It needs to be falling to the right. And once again, I'm going to go ahead and put all the dots there because it really doesn't take that long. And as it turns out, this is actually a dotted line, isn't it? Once again, dotted or dashed, same kind of word. Am I going to shade above this line or below this line? Why am I going to shade above it? Because it's greater than. Greater than the line is above the line. Now here's the thing. Do I need to put an up arrow over here? Why not? Because I already know it's got to be below that line, right? I already know my answer's not going to be anywhere up there. So where ultimately am I going to shade for this problem? Just right here, right? That's my solution. Please don't get all OCD on me and have to color in every single section of this box. I appreciate and I don't understand it because I don't have it, but I'm saying I appreciate and sympathize with your OCD, but please be careful and don't take a whole lot of time on that. Okay? So, if I give you a system, can you give me the graph of the system of inequalities? Yes. Okay? That's the middle section of your homework. Can I show you real quick what the first section of your homework says? And you'll see why I didn't have to do a whole lot of examples. I'm going to say to you this. Is this point a solution to this system? Well, this is pretty simple, right? Because I already have it graphed. So I could say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Is that in the shaded area? Yeah, so is it a solution? Yes. Could I do it without the graph? So 6 is greater than 9. Excuse me, less than. 6 is less than 9. Is that true? Yes. 6 is greater than negative 11. 6 is greater than a negative number, right? So that's true. So is this a solution to this system? Yes. Do you have to graph the system to tell if it's a solution? No. Could you check this using the calculator somehow? Remember, we could store this as x and this as y and enter this exact inequality? We could, couldn't we? Okay. Now, let me backtrack a little bit. Could I solve this system by graphing in my calculator? Absolutely. Okay. Do I want you to do that? No, I do not. And I think you'll see why in just a second. Could I graph it in my calculator to check and make sure that I did it right? Yes. Okay. But for actual work-wise, I need you to do this by hand. Can I show you why I need you to do it by hand? Okay. Here's why I need you to do it by hand. Give me just a second so I can make sure I have this correct for what I want. Here is why I want you to be able to do that first part by hand. Because here's the second part of your homework. Here's the graph. Give me the system. Can you do this in your calculator? No. And if you're not thinking the right way, if you're not thinking about how do we graph lines and how stuff like that by hand, you're going to struggle with this. Okay? So can we do this in our calculator? Yes. Yes, you can. I'm not trying to keep that hidden from you in any way. Okay? I'd rather you use it to check your work than to try to put this in the calculator and pretend you're graphing this on the graph right, because it'll be obvious if you did that. Okay? Just so you know. All right? Here, I want the system. If we're thinking the right way, if we're thinking about graphing stuff on paper, graphing stuff on a coordinate plane graph, we're going to have a lot easier time remembering how to write the system of this particular graph. Okay? So real quick, just in case you need a reminder, you probably don't, but just in case, do you mind if I remind you how to write the equation of horizontal and vertical lines? I think I said horizontal, but I meant horizontal. You know that, right? Okay. Horizontal and vertical lines. Horizontal and vertical lines, I tell which axis it's crossing and where. So if we're talking about this equation right here, or this line right here, what is the equation of that line? It's crossing the y-axis at 2, so it would be y equals 2, right? Now, I don't want to write that because this is not an equation. It is an inequality. And I know that because there's shading. I know it's still going to be y and 2, but the sign that I put in between is not going to be equal. What is it going to be? Why do you think it's going to be greater than or equal to? It is shaded above, and it's a solid line. That's perfect way to put it. Greater than or equal to. So let's give ourselves a reminder right here. It's shaded above, and it's a solid line. That's the reason that this is greater than or equal as opposed to just greater than or as opposed to a less than sign. Everybody understand that okay? Okay, how do we write the equation of this line right here? Well, it's a horizontal or vertical line, right? In this case, vertical. So which axis is it crossing and where? It's crossing the x-axis. 1, 2, 3, 4 at 4. So I'm just going to put the x in the 4. It's shaded to the left, so that's going to be less than, and it's going to be less than or equal to because it is solid. So it's shaded to the left, and it's a solid line. So shaded to the left gives me the less than, the solid line gives me the or equal to. Everybody okay with that? Okay. I have one more line. I have this one right here. How do we write the equation of a line? Like a diagonal line. Y is something. You want to go ahead and put that less than now? Why are you going to put less than?
Because it's shaded below.
It's shaded below. Why isn't it less than or equal to? Because it's a dotted line. So it's just less than. What's the y-intercept? 1, 2, 3, 4. What's my slope? 1. So just x plus 4. Now, some people found the slope first and then looked at the y-intercept. To that I say, okay. Right? There's no specific order that you have to go through to write the equation of a line. Most people see the y-intercept first, so they write it first, but it doesn't matter. Okay? So why is this just a less than then? Shaded below. And it's a dotted line. Questions? If I say to you, is this point a solution to a system, do you feel comfortable telling me the answer of yes or no? Do you feel comfortable being able to show enough work to prove that your answer is yes or no?
Yes.
Okay. If I give you this system, can you give me the graph of it? Even if there's 3 equations? Excuse me, 3 inequalities? Yes? Okay. If I give you the graph of the inequality, can you give me the system? Okay, so is this the system right here, or is there some other way we could write it? That's really the system, right? But we have a whole bunch of notes and stuff in there. So it might be nice if you came over here to the side and said y is less than x plus 4, y is greater than or equal to 2, x is less than or equal to 4. So some students earlier had a good question. Is that the order it has to be in? Is there a specific order that the system of inequalities has to be in when you write the system? No, as long as they are all there, right? If you have 3 lines as part of your system, you got to have 3 inequalities over here in your system. Okay? Any questions? How do you feel about this?